Hello friends, welcome to Learner's Planet. Friends, this is our second session for progression and series. In the previous session, we have already discussed the basics of arithmetic progressions. What is the nth term of an arithmetic progression? What is the sum of an arithmetic progression? In this session, we are going to discuss the basic problems based on arithmetic progressions. Okay, so you just get ready with your paper and pen and let's begin the session now. Now let's see this question. Number of terms in this arithmetic progression and 20th term from n we have to find out. Okay, so the arithmetic progression is 3, 7, 11 till 407. I assume this is nth term and we have to find out the value of n, obviously. So nth term is this. What is the formula for nth term? Nth term is equal to a plus n minus 1 d, where a is the first term, d is the common difference. So first term is what? 3, n we don't know, I put n minus 1 as it is, d is 4, and nth term is actually 407, right? So we find out the value of n from this equation. So n minus 1 into 4 is equal to 404, right? This 3 will be deducted from 407, will get 404. So this is 101. So n is equal to 105, right? So this is nth term and n is 105, that means this is 105th term. So if this is 105th term, that means how many terms are there? 105 terms, right? Now we have to find out the 20th term from the end. So what we can do, it is 407, then the common difference is 4. So next term is 403 and so on. We just write down the sequence in a reverse manner. Now from this side, I have written down the sequence in reverse manner. From this side, we have to find out the 20th term, right? Now what will be the 20th term? Again, a plus n minus 1 d t 20. So here n is 20. Okay, a is the first term, that is 407, n is 20, 20 minus 1, and d will be what? Minus 4. Be careful about it, right? So 407 minus, this is what? 19 into 4, 76. So 407 minus 76, that is 331, that is 20th term, right? 20th term from this side, that means 20th term from the end. Okay, I hope you are getting it. Just be careful. The mistake that students generally make is this d they write as positive, right? But the d common difference will be negative over here. So be careful about it. Okay. Then how many numbers of 2 digits are divisible by 3? So the first number that is divisible by 3 and having 2 digits is 12, right? And the last 2-digit number is 99, that is divisible by 3, right? Now we have to find out how many terms are there. Now if the numbers are divisible by 3, this is the first number, then the second number will be 15. Right? Then next will be 18. So common difference will be 3. Okay. So you know the first term, you know the last term, you have to find out the value of n, right? So this is Tn is equal to a plus n minus 1 d. Now this is nth term. We don't know which term is this, so I assume this to be nth term, right? So nth term is 99. Okay. A, that is first term, 12. And we have to find out the value. D is 3 and that is 99. So n minus 1 into 3 is equal to 99 minus 12. So n is equal to 30. That means there are 30 numbers having 2 digits and these are divisible by 3. Okay, so that's pretty simple. If you are asked about divisibility by 7, then the first number of 2 digits will be what? 14. Then the common difference will be 7. Okay, and so on. Now this question, The sum of three terms of an AP is 21 and the product of first and third term exceeds the second term by 6. Find the three terms. Okay, we have already discussed in our first session that whenever we have to assume the three terms of an AP, what do we assume? It's A minus D, A and A plus D, right? Now sum of three terms is 21. That means A minus D plus A plus A plus D is 21. That means 3A is 21. That means A is 7. So middle term is 7, right? Now first and third, the product of first and third term. First term and third term. The product is what? A minus D into A plus D. So that is A square minus D square, right? A minus D into A plus D is A square minus D square. That exceeds the second term, that is minus A, and that is 6. Okay? The product of first and the third term exceeds second term by 6. Now we got the equation. We know the value of A that I put over here. So that is 49 minus 7 minus 6 is equal to D square, right? So D square is equal to 49 minus 13, that is 36. So D is equal to plus minus 6. Okay? So it is 7, then it will be 7 plus 6, 13, and it will be 7 minus 6, 1. So the three terms will be 1, 7 and 13. If you use D is equal to minus 6, then this will be 13 and this will be 1, right? So no problem. The numbers, the three terms are 1, 7 and 13. They may be written in this order or maybe 13, 7 and 1, right? That really doesn't matter. Okay? The fifth term of an AP is 11 and the ninth term is 7. Find the 16th term. Fifth term T5 is equal to A plus 5 minus 1D, that is A plus 4D, and that is actually 11, right? Similarly, ninth term T9 is equal to A plus 9 minus 1D, so it is 8D is equal to 7, right? So we have two linear equations over here, or we can say a system of linear equations over here, so we can get the value of A and D, right? Now fifth term is 11 and ninth term is 7. That means D will be negative definitely. What I do? I deduct this equation from this equation. So 8 minus 4, 4D is equal to minus 4. So D is equal to minus 1. Now D, I put the value of D over here. So it is A minus 4 is equal to 11. So A is equal to 15. So first term of this arithmetic progression is 15 and the common difference is minus 1. Now we have to find out the 16th term. So T16th is equal to A plus 16 minus 1D, that means 15D. So A is 15 plus 15 into D is actually minus 1. So it is 15 minus 15, 0. Right? So 16th term will be 0. Okay, that's pretty simple. I hope you are getting it. Now see this question. In this question we have to find out the sum of the series, right? Now again this is an arithmetic progression because the common difference between two consecutive terms is same. Right? So first of all what we can do is we can find out the total number of terms in this sequence, in this series, right? Now this is what is nth term. And we have to find out the value of n, right? So what will be the formula for nth term? Tn is equal to A plus n minus 1 D. Here A is the first term, that is 5, and we have to find out D is 8, and this nth term is actually 181, right? So n minus 1 into 8 is equal to 181 minus 5. So that is 176. So n is equal to 23. So this is nth term. So this is actually 23rd term, right? Now you have the value of A, you have the value of D, you have the value of n. So it is easy for you to find out the sum of this sequence. So sum of arithmetic sequence is equal to n by 2 A plus L or n by 2, 2a plus n minus 1 d, right? Whatever you wish, you can use. Okay, now suppose if I use this a plus L, then s is equal to, number of terms are 23, so it is 23 by 2. First term, that is 5. L means last term, that is 181, right? So when you solve this, you'll be able to get the value of sum, that is sum of the series. This and this is same, this we have already discussed in our basic session. L, that is last term, is nothing but this, right? Nth term, that is a plus n minus 1d. So it is 2a plus n minus 1d, so I can write it as a plus n minus 1d, right? 2a is a plus n minus 1d. So this a plus n minus 1d is nth term or last term. So this can be written as L or Tn. So that is this formula and this formula. Basically both of them are same. Okay. Now how many terms of the series this be taken? Their sum is 513. Okay, so that's pretty simple. Sum is 513. Right, A is 54, D is the series is decreasing series, so D will be negative, that is minus 3. Okay, now we don't know the last term, right? That means precisely we have to find out the value of L, that is last term, or I can say N, whatever, right? So we just use the formula S is equal to N by 2 2a plus n minus 1 d, right? Now what? S is given to us as 513. N we have to find out. 2a, that means 2 into 54, plus n we have to find out, and d is minus 3. So I write minus 3. Okay, so here it is 513 into 2, 54 into 208 n minus, this is 3 into minus n, minus 3n square, plus this is minus 1 into minus, so plus 1 into 3n, right? So this is the equation that we are getting. I shift this to this side, 3n square plus minus 111n plus 1026 is equal to 0. Okay, so this is a quadratic equation we are getting. Again we can take 3 as common. I divide the entire equation by 3. So n square minus 37n plus is equal to 0. Okay, you just have to factorize it. You'll get n minus 18, n minus 19 is equal to 0. So n is equal to 18 or 19. That means either 18 terms are there or 19 terms are there, right? Now how is it is possible, right? You have to find out the number of terms in this series, so the sum is 513. Now if you take 18 terms, still the sum is 513, and if you take 19 terms, then also sum is 513. That is practically not possible. So what is happening over here? See, the 19th term is nothing but it is 0. Getting my point? So if you add 18th term or if you add 19th term, no problem, no difference is there, because 19th term is 0. Okay, and you can see this series is decreasing, right? So do not eliminate or do not worry about two answers over here, two values of n over here. Okay, 19th term will be 0, and you may be asked in your exams how just the explanation for two values of n, right? So what will be the explanation? That the 19th term is actually 0. Okay, now this question, good question, or I can say important also. Find the sum of first 24 terms of the AP A1, A2, A3 if it is known that A1 plus A5 till A24 it is 225, right? So the first term I suppose to be it is already given though a1, right? I assume the common difference to be d. So fifth term will be what? a1 plus 4d. 10th term will be a1 plus 9d. 15th term will be a1 plus 14d. 20th term will be a1 plus 19d, and 24th term will be a1 plus 24d, and that is 225. So how many a1s are there? 1, 2, 3, 4, 5, 6, right? So 6 a1 plus how many d's are there? 4 plus 9, 13, 13 and 14, 27, 27 and 19 is 46, 46 plus 24 is 70. I'm sorry, over here it will be 23d, right? Because it is 24. So here it will be 69d. Okay, so a1, I divide the entire equation by 3. So 2a1 plus 23d is equal to 3 7s are and 3 5s are. So 2a1 plus 23 is 75. This is the relation that we have got. Okay, now we have to find out the sum of first 24th terms. So what will be the sum of 24th term? As 24 is equal to 24 by 2, 2a1 plus 24 minus 1, that is 23 into d, right? Formula that we are using is n by 2, 2a plus n minus 1 d. Here n is 24. So precisely it is 12 2a1 plus 23d. Now 2a1 plus 23d, we know that it is 75. So it is 12 into 75, right? 12 5s are 16, 12 7s are 84 and 6 90, right? So sum of first 24 terms is 900. Okay, so if you don't get the second equation, do not worry about it. Just proceed with the problem with the next steps which are given, next information which is given. Okay, most of the students, what they think, see this just stuck up over here, right? They don't know what to do next, because 2a1 plus 23d is equal to 75. So there are two variables and you don't have any other relationship. Okay, so just proceed with the problems. You will be definitely getting the solution. As you can see over here, 2a plus 23d, we are getting this relation, and 2a plus 23d, we already know the value, right? So the problem becomes very simple. I hope you are getting it. Now that's an important one, frequently asked in exams. If mth term of an AP is 1 by n and nth term is 1 by n, show that the sum of mn terms is half of mn plus 1. Mth term is tm and mth term will be what? I assume the first term to be a and the common difference to be d, right? So a plus m minus 1 d. This is what? Mth term, and that is actually 1 by n. Similarly, nth term, a plus n minus 1 d is equal to, mth term is 1 by n and nth term is 1 by m. Okay, so by now we have got two equations, a system of equations we are having. So by solving this, we can get the value of a and d. So what I do is I subtract this equation from this. Okay, so m minus 1 minus n minus 1, so it is m minus 1 d, m minus n d is equal to 1 upon n minus 1 upon m. So it is actually m minus n upon mn, right? So d is equal to 1 upon mn. Okay, we got the value of the common difference. Now if I put the value of d over here, I'll be able to get the value of a. So a plus m minus 1 upon mn is equal to 1 upon n, right? So a is equal to 1 upon n minus m minus 1 upon mn. So we can take LCM. Mn is LCM. So m minus m plus 1. So that is actually 1 upon Mn. So A is also 1 upon Mn and D is also 1 upon Mn. Right? Now what we have to do? Sum of Mn terms we have to find out. So sum of Mn terms, the formula will be sum of Mn terms is Mn by 2, 2A plus Mn minus 1 D. If we have to find out the sum of n terms, we write n over here. If we have to find out the sum of mn terms, then we'll write mn over here. Right? Now just put the value of a and d. Mn by 2, 2 by mn, the value of a plus mn minus 1, and d is also 1 upon mn. So you can take mn as common. So I take mn as common. So this mn and this mn is cancelled. Right? So now what I'm having, 1 upon 2 mn minus 1 plus 2. So precisely it is mn plus 1. So what is the sum? Mn plus 1 by 2. And what we had to prove? Mn plus 1 by 2. Right? So that's very simple. Bit calculations are involved, but not at all difficult. Okay? So sum of mn terms is mn plus 1 by 2. That's proved. Okay? One more important question over here. See, all these questions are important but not at all difficult, right? But calculations are involved but not at all difficult. You have to be very careful while writing down the steps, right? Now sum of n to n 3n terms of an AP is this. Prove that this. Okay, I assume the first term to be A and the common difference to be D, right? So S1 is what? Sum of first n terms. So it is n by 2, 2a plus n minus 1 d, right? S2 is what? Sum of 2n terms. So I put n, 2n instead of n. So it is 2a plus 2n minus 1 d, right? Similarly, S3 is equal to sum of 3n terms. So 3n by 2, 2a plus 3n minus 1 d. Right? Now we have to prove this. So what we can do is we can solve right hand side and get the value of left hand side. So 3s2 minus s1. I start from right hand side. So that is 3s2 minus s1. Okay. So it is 3. S2 is what? This. So it is 2an plus 2n minus 1 n d, right? And I'm multiplying inside. So 2an plus 2n minus 1 n d, and here S3, that is plus 3n by 2, this 2 and this 2 will be cancelled, so it is 3an and plus 3n minus 1 into 3n by 2 d, right? That is 3s2 minus s1. Okay, now just expand it and take LCM. So it is 3 by 2, 2 into 2an, 4an. Actually it is S3, S2 minus S1. So by mistake I have written S2 plus S3, so I just remove this portion, I'm sorry. S2 minus S1, so S2 is 2an plus 2n minus 1 n d, right? 2an, 2n minus 1 d. Then minus s1 is there. So 2a into n by 2, that will be an minus n minus 1 into d into n by 2. N minus 1 into n by 2 d, right? So that is actually 3s2 minus s1. So let's solve it. We take LCM. 3 by 2, it is 4an. 2 into 2an 4an plus 2 into 2n 4n into nd, so 4n square d minus 2nd, right, minus 2an. Okay, then it is as it is, minus nd into n minus n square d plus nd. Now 4an minus 2an, that is 2an, 4n square d minus n square d, that is plus 3n square d, minus 2nd plus nd, that is minus nd. Okay, I can take n as common, so it is 3 by 2 n, 2a plus, I can take d also common from here, so it is 3n minus 1 d, right. So precisely it is 3n by 2 into 2a plus 3n minus 1 d. Okay, now what is S3? 3n by 2, 2a plus 3n minus 1d. We started with 3 S2 minus S1 and we are getting S3. Okay, so this is how it can be proved very easily. Okay, so we have discussed good number of problems in this session. In the next session we'll be taking more problems based on arithmetic progressions. So do revise this session and I'll see you in the next session once again. Bye bye.